Hello everyone, here is Afra Siab. Today we are going to solve Cambridge IGCSE Physics Paper 4 Theory Extended, held on October-November 2020 and paper code is 0625 with variant 43. Question number 1 is given as Part A. Figure 1.1 shows a trolley traveling down a ramp. The trolley has a piece of paper tape attached to it. The tape passes through a machine which makes a dot on the tape every 0.02 seconds. Figure 1.2 shows a section of the tape. Part 1. State how the dots on the tape shows that the trolley was moving with constant speed. So in the figure 1.2, both of these dots shows the distance traveled by the trolley and the dots are at the same distance. It means that the distance does not changes and time is also 0.02 second between two dots. Here is also 0.02 second. Time also remains same, that is 0.02 second. So if the distance is also same and times also same, then we can say that the body is moving with constant speed. So I write here same distance is traveled in same time. Part 2. When the trolley reaches the point P, the ramp is tilted so that angle X is greater. Describe and explain the change in motion of the trolley. So in the figure, the trolley is moving on the ramp. When it reaches at a point P, then the angle X increases. It means that the position of trolley may be like this so that angle X increases. So here you can see that the angle increases, means that the slope is higher here. And the weight of trolley is acting in downward direction, which also increases because of high slope. Due to the increase in weight, the weight is acting downward, there must be the net force acting on it, that is resultant force, and it also increases. And we know that F is equal to ma according to second law of Newton. When force increases, body accelerates. Acceleration also increases. So acceleration increases. I can simply say that when the angle X increases, the body accelerates. So I write here trolley accelerates. And why the trolley accelerates? Because a resultant force acting on the trolley. Next part is B. Here is a graph, that is speed time graph. So a trolley is released from top of the ramp. The figure 1.3 shows the speed time graph of the trolley. On the x-axis we have taken time, while on the y-axis we have taken speed. Using figure 1.3, calculate the distance traveled by the trolley in the first 0.5 seconds. Here time is 0.5 seconds and we have to calculate the corresponding speed on the y-axis to calculate the distance, and we know that the distance will be equal to the area under speed time graph both are meeting at this point, and the speed at this point is 0.75 and time is given 0.5 seconds. So distance must be equal to the area under this curve, and it's a triangle. So I write here 1 over 2 speed multiplied by time, 1 over 2 speed is 0.75 multiplied by 0.5. So distance comes to be 0.19 meters. Part C. Figure 1.4 shows a metal ball at rest in a tube of liquid. Metal ball first of all is at this position, and at this position it is at rest, means that the velocity at that point is equal to 0. The ball is released and reaches the terminal velocity at point x. This is the point x, and at that point ball reaches at terminal velocity. Explain the motion of ball as it falls from rest until it reaches at point x. At point x when it attains terminal velocity. Use the idea of force and acceleration in your answer. So at that point I consider it A. At that point the ball is at rest. When it falls, its speed going on increase. So I consider that it's a metal ball, and when it falls downward, its weight is acting in downward direction. As the ball falls, its speed going on increases and the weight is acting in downward direction. It means that there must be the net resultant force in the downward direction. And due to this force, body accelerates. Means that the speed of body increases. Due to increase in speed, there must be an equal but opposite force that is acting in upward direction, and it is the resistance force. With the increase in speed, the magnitude of resistance force going on increase, and when the ball reaches at point x, the upward force must become equal to the downward force. Means that the force that is acting downward is weight and upward is force due to resistance. Both of these becomes equal. Then body attains terminal velocity, and at terminal velocity body moves with constant speed. So I write here because of downward resultant force, metal body will accelerate. As velocity increases, resistive force also increases. That is due to the air resistance. At point X, upward force becomes equal to downward force. So metal ball travels at constant speed, which is the terminal velocity of body. Question number 2. Figure 2.1 shows a cliff edge with water below it. You can see here it's the surface of water and it's a cliff and ball is placed over it and the height of cliff is 115 meters. A ball falls over the edge of the cliff. The mass of ball is 160 grams. The height of the cliff is 115 meters. Part A. Calculate the vertical speed of the ball as it hits the water. Air resistance can be ignored. Here we have to find out the speed. And as the ball falls down, then height goes on decreasing, but the ball gains kinetic energy. It means that loss of potential energy must be changes into the kinetic energy. So I write here loss of potential energy will be equal to gain in kinetic energy. And potential energy is actually the energy possessed by a body due to its position, while the kinetic energy possessed by a body due to its motion. So the formula of potential energy is mgh. It will be equal to gain in kinetic energy, and kinetic energy is equal to 1 over 2 mv square, where m is the mass, v is speed, m is mass, g is acceleration due to gravity, and h is the height. So we have to put the values in this equation. This m is cancelled by this and it comes to be gh is equal to 1 over 2 v square. Here v comes to be square root of 2gh. We have to put values here. V is equal to square root 2 multiplied by 10 and the height is given as 115 meters. So V comes to be 48 meter per second. The vertical speed is 48 meter per second. So I write here part B. Calculate the vertical momentum of the as it hits the water. Here we have to calculate the momentum, and momentum is the product of mass and speed. Mass of body is given and it is equal to 160 grams. We have to convert into kg. So I divide it with 1000. And the vertical speed we already calculate is 48 meter per second. So momentum comes to be 160 multiplied by 48 divided by 1000. So it comes to be 7.7 Newton second. The unit of momentum is Newton second or kilogram meter per second. So I write here momentum comes to be 7.7 Newton second. Question number 3, A part 1. Speed is a scalar quantity. State one other scalar quantity. So first of all, we have to know about what is scalar quantity. The quantity that has only magnitude. I write here the quantity that has only magnitude. The other quantity that is scalar is distance. Part 2. Velocity is a vector quantity. State one other vector quantity. So vector quantity is actually quantity that has magnitude and direction. So I write here the quantity that has magnitude as well as direction is known as vector quantity. So the vector quantity is displacement. Displacement is actually has both magnitude and direction. That's why it is a vector quantity. Part B. There is a figure 3.1 shows a model car traveling at constant speed on a flat circular track. So here is a car that is traveling into the circular path. The speed of car is 0.30 meter per second. In one complete revolution around the track, the car travels 3.9 meter. So the speed is given 0.30 meter per second and the distance he travel is 3.9 meters. Part 1. Calculate the time taken for the car to complete one revolution around the track. We have to calculate the time and we know that the speed is equal to distance divided by time. And we have to calculate time. So time will be equal to distance over speed. Distance is given 3.9 meter. 3.9 divided by speed is 0.30. So time comes to be the value of time is 1.3 seconds. So I write here 1.3 seconds. Next part. Part 2. On figure 3.1, draw and label with the letter F an arrow to show the resultant force acting on the car. So we have to show the resultant force that is acting on the car. So going back to the diagram 3.1, and when the body is moving into the circular path, then the net resultant force is always acting towards the center of circle. In order to move the body into the circular path, there must be the net force that is acting towards the center of circle. So the direction of that force will be towards center. I'm going to draw it. And we have to represent it with F. So it is the direction of net resultant force on the car. Next part is part 3. The speed of car increases and at point P, you can see in the figure 3.2 there is a point P. On figure 3.2, the car does not stay on the track. It means that at a point P, it does not move into the circular path. 1. Suggest in terms of force acting on the car why the car does not stay on the track at a point P. So I already discussed that the resultant force acting on the body in the inward direction for a body to move into the circular path. So if there is no net force that is acting towards the center of circle, so the body will not move into the circular path. It may move into the straight path or any other path. So for a body to move into the circular path, there must be a net force towards the center of circle. Here I write that the net force is insufficient to keep the body moving into circle. So I write here resultant force is insufficient. Part 2. On figure 3.2, draw and label an arrow with S to show the direction of motion of the car as it leaves the track at point P. So in the figure 3.2, we have to label with S the direction of motion of car when it does not move in the circular path. So when it does not move into the circular path, then it will move in a direction that is tangent to that point P. So I draw a normal line at point P. The car will move in this direction. It will be a straight path. And we have to mention this with the S. So I write here S. So this is the direction of the motion of car when it does not move into the circular path. It moves along a straight line that is tangent to point P. Question number 4. In figure 4.1, the circles represent molecules in different state of matter. Part A. Identify the state A, B and C. In the figure you can see that A, B and C. The molecules are shown, and in the figure A, the molecules are close to each other, but there is a small distance between them. In B, the molecules are very close to each other and the spacing between them is very small as compared to figure A. And in C, the molecules are very apart from each other. So the B is actually for solids, because in the solids molecules are very close to each other and the spacing between them is very small. So I write here B is solid and A is liquid, because in A the molecules are closer but there is a spacing between them. So I write here liquid. And in C, it's a gas and the molecules are very far apart from each other. Part B. Explain in terms of forces between molecules why gases expand more than liquids when they have the same rise in temperature. Assume that the pressure remains constant. So here pressure is constant, but when we increase the temperature, gases expand more as compared to liquid. It is because that the molecules of gas are very apart from each other. The spacing is larger for gas molecules and the attractive forces between them must be very small. So I write here average distance between molecules of gas is greater and attractive forces between them are lesser, due to which gas expand more as compared to liquid. Part C. Here is the figure 4.2 and figure 4.2 shows the cylinder and piston. The volume of gas in the cylinder is 3400 cubic centimeter. The pressure of gas in the cylinder is 0.90 into 10 to the power 5 Pascal. Part 1. The piston is moved to the left and fixed in a new position. The pressure of the gas in the cylinder increases to 2.5 into 10 to the power 5 Pascal. Assume that the temperature of gas does not change. Calculate the new volume of gas. First of all, volume is given and pressure is given. And again the piston is moved to the left and then pressure increases and we have to calculate the volume. By using Boyle's law, because here temperature is constant, then we use Boyle's law. According to Boyle's law, when temperature is kept constant, then pressure is inversely proportional to volume. So I write here P is inversely proportional to volume R. P1 V1 is equal to P2 V2. Here V1 is 3400 cubic centimeter. P1 is given 0.90 into 10 to the power 5 Pascal. And the new pressure is also given P2, which is 2.5 into 10 to the power 5 Pascal. By using this value, we have to calculate V2, and V2 is equal to P1 V1 over P2. So P1 is given 0.9 into 10 to the power 5 multiplied by 3400 divided by 2.5 into 10 to the power 5. So V2 comes to be 1200 cubic centimeter. So the new volume is 1200 cubic centimeter. Part 2. The gas in the cylinder is not heated. The piston remains fixed in the same position. It means that volume does not change. State and explain in terms of molecules any change in pressure of the gas. So when the gas is heated, but its volume does not change. Gas is heated means that we are increasing temperature, and when temperature is increases while the volume is kept constant, the gas particles gains more kinetic energy. Gas particles gains energy. And due to this high energy, they move with very high speed. Speed also increases and they collide with each other frequently, due to which they exert pressure. So I write here pressure increases and why the pressure increases? Because as the energy of molecules increases, molecules move faster and more light with the piston. Due to more collision, the pressure increases. Question number 5. Figure 5.1 shows two metal plates A and B with a radiant heater placed midway between them. Here is a figure 5.1 and it's a heater that is placed between the metal plates. It's the metal plate A and it is B. The metal plate A is made up of shiny surface while the B is made from dull black surface. So metal plate A is shiny, the metal plate B is dull black. A piece of cork is attached to the each plate using wax. The wax is a solid at room temperature and has a melting point of 37 degrees C. Part A. State and explain what happens to the pieces of cork a few minutes after the heater is switched on. So when we switched on this heater, it emits infrared radiation in all the directions. And this radiation also passes through the metal plates. When these radiations reaches plate B, as dull black plate is B and black is a good absorber. So all of the radiation are absorbed by the plate B. It means that all of these are passed through the B and then reaches the wax, due to which wax melt. While when this radiation reaches the metal plate A, that is a shiny metal plate, and we know that the shiny surface is good reflector. So this surface will reflect all of the radiation in backward direction. Therefore, the wax will take time to melt because all of the radiations are reflected in backward direction. So the wax in the plate B will melt first as compared to the metal plate A. So I write here wax on plate B melts before wax on plate A. Therefore, cork on plate B falls off before plate A because black surface is a good absorber and shiny surface is a good reflector. The black surface is better absorber of infrared radiation than shiny surface. Part B. Give the name of method of transfer of thermal energy in the solid metals. So in the solid, the energy transferred due to the conduction, because the molecules of solid are very close to each other, so there will be greater conduction. So due to the conduction, the thermal energy transferred in the solid metal. Question number 6, Part A. Sound waves consist of compressions and rarefactions. Explain in terms of compression and rarefaction. Give your explanation in terms of spacing of molecules and pressure for sound wave in air. So sound waves basically longitudinal wave, and these are made up of compression and rarefaction. Compression is the portion of wave where the molecules are closer, while rarefaction is the portion of wave where the molecules are far apart from each other. So when I draw the sound wave, that consists of compression and rarefaction. It will be just like this. This is compression and its rarefaction. So you can see from here that the distance between these are very small. So it is compression and here the distance is very large. These are rarefactions. These are rarefactions. So I write here compressions, molecules closer together, than normal, and pressure is higher at compression than normal. Rarefaction molecules are molecules further apart than normal, and pressure is lower than normal. Part B. A musical instrument emits a sound with a frequency of 4.4 kHz. The speed of sound in air is 340 meter per second. Part 1. Calculate the wavelength of sound. So we know the relation V is equal to F lambda. Here V is speed, F is frequency, and lambda is wavelength. We have to calculate lambda. Lambda will be equal to V over F, and frequency is given 4.4 kHz, and it is equal to 4.4 into 10 की power 3 Hz. So wavelength comes to be 340 divided by 4.4 into 10 की power 3, and it comes to be 0.077 meters. So wavelength is 0.077 meter. So I write here part 2. The frequency of the sound emitted by the instrument is changed to 5.1 kHz, and the amplitude of sound is increased. Without calculation, state what happens to the speed of sound. Second, the wavelength of the sound. So first, frequency is 4.4 kHz, and then frequency is increased and it becomes 5.1 kHz. As the sound wave travels in the same medium, so the speed remains unchanged because speed depends upon the medium. Here medium remains same, so the speed of sound will stay same. Second, the wavelength of sound as the frequency increases according to V is equal to F lambda. Here V is constant because it does not change, it remains same, and the frequency increases. If we increase the frequency, then its corresponding wavelength should be decreased to keep the speed constant. So the wavelength of sound decreases. Question number 7, part A. State 2 uses for infrared radiation. So infrared radiation used in remote controls and infrared sensors, alarms and specific electrical appliances. So I write here remote control and in infrared sensors are alarms. Part B. X-rays are used in hospitals to help treat patients. Suggest and explain 3 precautions for the safe use of X-rays. So we have to take some precautions that we have to limit the intensity of X-ray beam and have to limit the dose. We have to shield the body of the patient and then absorb the radiation, and we also have to limit the time of exposure, and we have a small distance from the source, and then we have to reduce the radiation. So I write here limit intensity of X-ray beam and to limit dose. And we also have to limit the time of exposure. And shielding of other parts of patient and then to absorb the radiation. Next part C. State the speed in a vacuum of 1 microwaves and second one X-rays. In the vacuum, all of the waves move with the speed of light, and the speed of light is 3 into 10 to the power 8 meter per second. So the microwave and X-rays move in the vacuum with the same speed. So I write here 3 into 10 to the power 8 meter per second. Also for the X-rays, the values remain same. And it's the value of speed of light. Part 2. State a possible frequency for an ultrasound wave. So human ear can respond to frequency lies between 20 to 20,000 Hz. But the frequency that is above 20,000 Hz is actually the ultrasound wave. So the frequency for the ultrasound wave is greater than 20,000. The Hertz is the unit of frequency. Question number 8, Part A, 1. Figure 8.1 shows an electrical circuit. The resistor has a resistance of 4.0 ohms. The reading on the voltmeter is 3.0 volt. Here is the voltmeter and it's the resistor. The value of resistance is 4.0 ohms and voltmeter shows reading of 3.0 volt. Calculate the current in the resistance. We have to calculate the current in the resistor by using Ohm's law. V is equal to IR. Here voltage is given, that is 3.0 volt, and resistance is also given, which is 4.0 ohm. So I can easily find out current from this equation. V over R, I is equal to 3.0 over 4.0, and current comes to be 0.75. The unit of current is ampere. So I write here 0.75 amperes. In this figure, you can see that this is our diode, and the arrow shows the positive side of the diode, while the vertical line shows the negative terminal of the diode. So positive terminal of the diode is connected with the positive of the cell, while the negative terminal is attached with the negative terminal of the cell. So next part B. Figure 8.2 shows the same circuit with one component reverse. State the reading on the voltmeter and explain your answer. In this circuit, you can see that the diode is reverse bias because diode is formed. This is the positive terminal of diode, while this vertical line shows the negative terminal of the diode. And this vertical line is negative while the arrow is positive. Negative terminal of the diode is attached with the positive terminal of the battery, while the positive terminal of the diode is attached with the negative of the battery. It means that these are reverse bias, and when there is a reverse biasing, no current flows in the circuit. No current flows through the circuit, due to which the voltmeter also gives zero reading. So I write here reading of voltmeter is 0 volt, and we also have to explain here diode is connected in reverse bias, so no current flows through the circuit. So I write here diode do not pass current in reverse direction. Part B. Figure 8.3 shows the symbol for a logic gate. Here two inputs X and Y, and there is a single output Z. The truth table for this logic gate is shown in table 8.1. So there are two inputs X and Y, and there are four combinations of these inputs 0, 0, 0, 1, 1, 0 and 1, 1. And there is a single output Z, and these values are given. So we have to identify that which kind of this logic gate. So it's a AND gate. In the AND gate, when both inputs are high, then output will be high, otherwise output will be low. So you can see from here that the combination 1, 1, it means that both inputs are high, then the output will be high, that is equal to 1. Otherwise, all the inputs and all the outputs are 0 for all combinations of inputs. When we take 0, 1, the output is also 0. So this gate is basically AND gate. So I write here AND gate. There is another circuit in part C. Part 1. A student designs the circuit shown in figure 8.4 and compute the truth table for this circuit in table 8.2. So in the circuit there are two inputs A and B and a single output E. We have to complete the truth table. So when both of inputs are low, both of inputs are high, or if any input is low and the other is high, then we have to fill the table C, D and E output. You can see in the figure 8.4 that these gates are actually NOT gate. First of all, we have to know that what is NOT gate. NOT gate is basically the combination of OR gate and NOT gate. And when we draw the truth table for this, it will be just like so. If you consider two inputs A and B and I apply OR gate, then it will be A or B. So inputs are 0, 0, 0, 1, 1, 0 and 1, 1. In the OR gate, when any one of the input is high, the output will be high. So here 0, 0 are low inputs, so output will be low. Otherwise, in all combination, there is a one high input, so the output will be high. So I write here 1, 1 and 1. When we have to apply NOT gate over it, then 0 changes into 1 and 1 changes into 0. So this is basically the truth table of NOT gate. So when I have to fill this table, C is the output of NOT gate, and according to this table I can fill truth table. So when there is a 0, 0, both inputs are low, then the output will be 1. For 0, 1, the output will be 0. Also 1, 0, the output is 0, and for 1, 1 input, output is 0. Similarly for D, no here E. E is the output when I combine C and D and apply NOR gate over it. It means that when inputs are 1 and 1, the output will be equal to 0, that is E. So I write here 0. For 0, 0, output is 1, so all combination will be equal to 1. So this is the truth table for this circuit. Part 2. A single logic gate can be used to produce output E. In figure 8.4, with the input A and B shown in table 8.2, state the name of this logic gate. So the circuit that is given in 8.4, this circuit can be replaced with a single logic gate. So we have to tell the name of this logic gate. In the table 8.2, we can see that when inputs A and B both are 0, the output E is 0. When the input are 1 and 1, the output is 1. So when the inputs are 1 and 0, the output is also equal to 1. So we can compare this E with A plus B in the other table, that is for OR gate. So both of outputs are equal. We can simply say that this circuit can be replaced with the OR gate to get the output E. So I write here OR gate. Question number 9, part A. Electrical power is produced in a power station by an alternating current AC generator. The output of generator has a voltage of 22,000 volts. The electrical power is transmitted at a voltage of 400,000 volts. Explain why the electrical power is transmitted at a voltage of 400,000 volt and not 22,000 volt. So at the power station, if you consider that it's the power station, here the generator output is 22,000 volts. But when this power is transmitted through the transmission line, then it is transmitted at the voltage of 400,000 volts. Why this power is not transmitted at 22,000 volts? So first of all, we know that power loss is equal to I square R. We want to reduce the power loss. When I reduce power loss, it means that I am decreasing the power loss, and when the power loss decrease, the current also decrease because both of these are directly proportional to each other, and because current is decreasing by the relation P is equal to IV. By keeping the power constant, when current is decreasing, then the voltage should be increased in order to keep the power constant. And when the voltage is reduced, when the voltage is increased, it means that the transmission of the electrical power is at higher potential, that is 400,000 volt, and when power loss is less, energy will be more, and the device should be more efficient. So I write here high voltage result in low current for same power as heat loss is depending on current when current is reduced. Energy loss will be less in transmission line. Part B. Part B. A computer contains a transformer. The input voltage to the transformer is 240 volt. The output voltage for the transformer is 20 volt, and the output current is 2.3 ampere. The efficiency of the transformer is 90%. Calculate the input current to the transformer. Here we have to calculate the input current. We know that power is the product of current and voltage. P is equal to IV. Here efficiency is given, and efficiency E is equal to output power over input power multiplied by 100. So here efficiency is given 90%. Output power, I write here the product of voltage and current over input power is the product of input voltage over input current. Output voltage is given 20 volt. 20 multiplied by output current is 2.3 and input voltage is given as 240 and we have to find out the input current. So I write here I input is equal to 20 multiplied by 2.3 over 240 multiplied by 90 and then I have to multiply it with 100. It comes to be 0.21 amperes. So input current is equal to 0.21 amperes. So the input current comes to be 0.21 amperes. I write here 0.21 amperes. Question number 10. Figure 10.1 shows a relay. Figure 10.1 there are two circuits A and B. And in the circuit B there is also a motor. Circuit A consists of current carrying coil and there is also a soft iron armature that is fixed at the pivot point and there is also contact at the circuit B. Part 1. The switch in the circuit A is closed. Describe how this operates the motor in the circuit B. First of all, the switch in the circuit A is closed. When we close the switch, then there will be the current in the circuit A and it will flow from positive to negative terminal of the battery. It will flow in this direction and also passing through the windings of this coil in this way, and then it comes at the other side and it flow towards the negative terminal of the battery. So when we pass current through the coil, it gets magnetized so that there is a magnetic field in this coil and the magnetic field will be just like this. These are the magnetic lines of force. Due to this magnetic field, the soft iron armature is attracted towards this coil and it will move in this direction. It will make contact with this magnet in such a way that the other side of the soft iron armature moves upward and it will be in touch with the contact, due to which the contact touch with each other and they also touch with each other and it becomes a closed circuit. And when this becomes closed circuit, then of course there will be the current in the circuit B and the motor will work. In this way, the motor will work when the circuit B is closed, when circuit B is open but circuit A is closed. So I write here when switch in the circuit A is open, there will be no current in the circuit, but here we have to close the switch, so there must be current in the circuit. So I write when switch in circuit is closed, the coil become magnet and coil attract soft iron armature. The other end of armature moves upward and contact touches. Due to which there will be a current in the circuit B, and this operate the motor in the circuit B. Part B. The switch in the circuit A is open. The soft iron armature is replaced with the steel armature. Now we have replaced the soft iron with the steel. The switch in the circuit A is closed. Explain what happens when the switch in the circuit A is then reopened. So first of all, we go back to the circuit. And when the switch in the circuit A is opened, then there will be no current through the circuit A. And then this coil is just a coil, it does not act like a magnet. So when there is no magnetic field, then the soft iron armature will push away and it come back towards its original position, and it also move from the upper side in downward direction, and the contacts separate each other, due to which there will be no current in the circuit B and the motor in the circuit B does not operate. And then we have to replace the soft iron armature with the steel. When we replace this and then again close the switch in circuit A, then again the current start to flow from positive to negative terminal of the battery, and also current passing through this coil, due to which there is also a magnetic field. And the magnetic lines of force will move from one just like this. And this steel armature will move toward the coil due to the magnetic field, and the other end is move upward and it touches the contact. The contact touches each other, and again there will be the current in the circuit B and motor will operate. After that we have opened the switch in circuit A. When I again open the switch, then first of all the current through the circuit A stops and the magnetic field also vanishes, and this coil is just like a coil, it's not a magnet. But at that time the steel has a property that it remains magnetized even there will be no current in the circuit. So due to this property, steel remains magnetized. So I write here steel remains magnetized when there is no current in the coil. The current in circuit B does not stop when switch in the circuit A is stopped. It is because the steel is magnetized and it remains magnetized, due to which the contact points in the circuit B it touches each other. There will be the current in the circuit B and it will continue to flow. Question number 11, part A. Figure 11.1 shows a beam of alpha particles, beta particles and gamma rays directed between two metal plates P and Q. The metal plates are parallel and there is a large potential difference between them. Plate P is positive and Q is negative. On figure 11.1, draw the paths of each of these radiations between the plates and after leaving the plates. Label the path alpha, beta and gamma. So in figure 11.1, we have to show the path of alpha radiation, beta radiation and gamma rays. First of all, alpha radiations are helium nuclei and these are positively charged. And beta radiations are electrons and these are negatively charged. While gamma rays are neutral and these are chargeless, they don't have any charge. And there are two plates P and Q. The charge on plate P is positive while on the Q is negative. And the beam of alpha particles, beta particles and gamma particles coming in this direction. And we have to show the path in which these are deflected or either these are deflected or not. So as the gamma ray is neutral, so there will be no deflection in the case of gamma ray. And alpha radiations are positively charged. It means that they will be deflected towards the negative plate, which is Q plate, and beta radiations are negatively charged, due to which these are attracted towards the positive plate, which is P. So first of all, I draw the path for alpha radiation. Alpha radiation coming in this direction and then they bend towards the negative plate, just like this. While the deflection in the case of beta radiation is more as compared to alpha, because the beta particles have different energy and they will show different deflection. So the beta radiation will be just like this, or they may be this. The deflection is more as compared to alpha rays, and the gamma rays will go straight forward, they don't deflect it. So the path of gamma rays is this. These are gamma rays, these are alpha radiation and these are beta radiations. Part B. State and explain one practical application of gamma rays. The gamma rays are used in the sterilization of equipment and it is used to destroy the bacteria. So I write here, because they destroy bacteria.